So it's time for us now to turn our attention to some anaerobic fitness tests. So anaerobic, obviously, we're going to be looking at tests here of shorter duration, of higher intensity. So let us get started straight away. And the test I want to introduce you to initially, and it's a test I kind of have some fairly strong memories of, is the idea of a Wingate test. Now, let me say before this, some of the tests we're going to do here are closer to what we might call laboratory type tests. So you may not get to experience these in person, depending on where you're studying and what resources you have available to you. Now, I would just add that having a go at these tests is the best way to really grasp an intuition for them. But that said, let's see if we can get you the key information regarding each of them. So this Wingate test, the key thing I would like you guys to take away about this is that this is based on the use of a flywheel, and this flywheel is based on what we call an ergometer. And I'd like to kind of try and draw this for you. So imagine that what I've got here is the front wheel, perfectly round of course, is the front wheel of a static exercise bike. So think about the kind of bike you might see in a gymnasium or something like that. But this bike has got, this front wheel has got, the flywheel has got something kind of interesting about it. Around the actual flywheel itself would be a sort of blackish grey kind of tape. And that tape sits inside a groove on the wheel itself. And hanging from one end of this tape is a weight. And this weight in this particular context is 1 kilogram of weight. So imagine that this weight is, of course, acting downwards with a force of, the mass is 1 kilogram, so we'd effectively get 9.8 newtons of force, 9.81 newtons of force downwards. So of course what's happening is that this green, as I've drawn it, this green tape is gripping onto that flywheel, so that when the athlete gets onto the bike and starts turning this wheel, because it's linked to the drive shaft of the bike, they're of course fighting against the resistance of this 1 kilogram weight. So it's a very specific level of resistance. So how does it work? So we have this flywheel, this ergometer. Now what the performer's going to do is they're going to perform at max power. So they're going to basically get onto this ergometer, this bike, and they're going to go at flat out pace as hard as they can. And they're going to do this for 30 seconds. Now, once this is done, we're effectively going to be able to plot a graph of power. And I'm just going to sketch it for you. I encourage you to go and Google these yourselves and see some real ones. So what we're going to have here is we're going to have a graph here, and of course along here we're going to have time, some 30 seconds of time is going to be along that x-axis, and what we're going to have on the vertical, on the y, is we're going to have power, and that power is going to be read in watts. So of course what is going to happen here when the performer starts to pedal as hard as possible? Well, their wattage is going to shoot up rapidly. And the first thing we're interested in is, what is this peak point? What is that peak power output? And of course what's going to happen is it's going to remain stable at the top, and then after some seconds, because the ATP PC system starts to decline, we're going to get a decline in performance until, let's call this 30 seconds here. Let's say that that's 30 seconds there. And what we're of course interested in is, if we go across here, here's our peak power here compared to our power after 30 seconds. Well, also, what is the difference between these two power outputs? In other words, how much power fatigue has actually occurred? So, in this test, we measure both peak power, and what we call power reduction. Which sounds like the kind of thing you would do to save your energy bills a little bit. But in this case, we're looking at how big was this decline over that 30-second period. All right, so it's an interesting one. Now, we always want to talk about advantages and disadvantages. We like this test because it's pretty reliable. It produces pretty consistent results over time. And the other thing, this is not always an advantage in life, but this is a well-established test. It's a well-established, well-respected test. And of course, therefore, the data that's behind it and the comparison tables are pretty reliable in the main. Now, negatives, we've got one performer only. Okay, so that's a limitation. It's effectively a laboratory test. This performance is extremely fatiguing. This can even lead to faintness and dizziness and people collapsing after that 30 seconds. If you don't believe me, maybe you'll get a chance to do this sometime. And the other thing is that, of course, cycling does have a technique. So we have to take into account that someone might have a completely different cycling technique to somebody else. But nevertheless, there we go. All right, let's move it on. I want to talk now, and I'm going to sort of do this one in blue, about what we refer to as the MAOD, which, despite what it looks like, is not a baddie in Doctor Who. That was a terrible joke. I have no idea why I said it. But in fact, what it stands for is the following. It is, and you must be specific with this, okay? It is maximally accumulated oxygen deficit. Okay, so that's where our acronym comes from. So that's fairly obvious. Now, how does this work in practice? How are we going to perform this anaerobic test? Well, the first thing we are going to do is we're going to do 10 lots of 4 minutes on a treadmill. Okay, so we're going to have 10 bouts of 4 minutes on a treadmill. And the important thing is this point I'm going to make now. The 10th bout, which of course, is going to be, and I should say, every time you go on to the first, the second, the third, the fourth, the fifth, the 10th bout, the intensity of the exercise bout is increased, either the speed or the incline. But the 10th bout is calculated to fatigue. Okay, so basically the 10th bout has got to go to a level where you just can't keep going, designed after that 4 minute period is up. So, important. Why do we have 10 bouts? Why not just exhaust on the first one? Well, the first few bouts, like 1 to 4, the first few bouts give a prediction of output, and the later bouts actually are a measurement, okay? And here we've actually got of VO2 max, a prediction of VO2 max. Now, the last bout, which is what I was talking about here, the last bout gives the measure of VO2 max. Okay, so what we're really interested in, is that the MAOD is the difference between the prediction and the measurement. Okay, so that's where this test sits. It's a very interesting test because, yes, we're measuring VO2 max, but we can do that in other ways. This test specifically gives you a measure of to what extent an oxygen deficit is built up, and that's what it's for, and that's why we still consider it to be anaerobic, even though we're measuring effectively VO2 max. So, positives, we consider the test to be accurate, which of course is a very good thing because it makes the test valid. But on the negative side, it can only be conducted in the laboratory. It's laboratory only. So the practicality, therefore, diminishes as a result of that. All right, we've still got a lot to do, so let's make sure we crack on here. Otherwise, it's going to be a very, very lengthy video. I want to introduce you to another acronym here. It's what we call the RAST. And let's first of all define this thing. We refer to RAST, or RAST is repeated anaerobic, let me see if I can squeeze that in, repeated anaerobic sprint test. So clearly an anaerobic test, repeated anaerobic sprint test. And the key things I'd like learners to grasp about this is that it's 6 bouts of a 35-meter sprint. Okay, so 6 35-meter sprints, and get ready for kind of realizing this is going to be pretty tough. That in between each sprint there is only 10 seconds recovery. 10 seconds recovery in each sprint. And therefore, how do we calculate based on this? Well, what we do is we take the mass of the performer, so how heavy they are, we multiply that by the distance squared, which of course is always going to be 6 times 35 squared. And what we're then going to do is we're going to divide that by the time it takes for the 6 sprints in total, because of course it's going to differ from person to person, and we cube that time. And as a result of that, it gives us an illustration of anaerobic power, So what we're really interested in is that this methodology provides a score for comparison. Okay, a score for comparison. Now, first of all, I'd encourage you to do this, but think about what your 6th bout of the 35-meter sprint is going to be like when you've only had 10 seconds to recover. It's going to be significantly slower than the first one, assuming you've gone flat out. Now, why is this test a good one? Well, first of all, it's considered to be a very effective alternative to Wingate. And when you might think, well, why do we need that alternative? Well, the Wingate test is a lab test. This test you can do in your, we can effectively do it on the school field in the sports hall. 35 metres might be a bit big for a sports hall, maybe the diagonal, but you've got an alternative which can be done as a field test. And the other point I'd make, and this is on the negative side, of course, is that because we're timing over 35 metres, what's that going to take? Some 5.5 seconds, 6 seconds, something like that? Well, we're going to get timing errors within this test. So, of course, that is in itself, potentially a bit of a negative. So that RAS test is a really nice test as an alternative to Wingate. Next one, we're going to have a look at what we call the Cunningham, and Faulkner test. Not a very catchy name. Clearly the people who developed this named it after themselves. A little bit narcissistic in my opinion, never mind. What do we have here? We have a treadmill test. Okay, a treadmill test. And it's extremely simplistic because this is how it works. You could try this in your gym. Make sure you put that little kind of emergency stop belt on in case you fall off. So the treadmill is set for 8 miles per hour. The treadmill is set for 11.3 degrees of incline. Now, trust me, that is steep. And effectively, what happens is that the performer runs to exhaustion. Now, the interesting thing about that is that most people, I'll try and figure out how long it would take you, but most people tend to exhaust in a particular time. So we take the time, and for most people, is going to be less than 60 seconds, so very anaerobic. You might want to think, well, could you do better than that? But trust me, it's a pretty tough thing to do. And then, of course, what do? Is we compare the score to those normative scores. So, positives, it's a very simple test. We can do it with I suppose you do need a treadmill at the end of the day. It's not that simple, but relatively simple. Negatives, we've got one participant only, so that's a limitation. And the other thing is kind of what I've mentioned about the safety. We've got to be careful with this fatigue on the treadmill, because if someone falls off, I've seen this happen on a number of occasions, it can do people some proper damage. So that's something we want to be a little bit careful of. All right, next one. In fact, this is the final one I'm going to look at in detail. As I noisily turn my page, this one, you're going to have to excuse me, because I really always have to check the spelling of this one really, really carefully. I'm going to do it in a minty green. So this is the test that we refer to as the Megger. By the way, I know someone's going to tell me that I'm pronouncing these wrong and bastardizing this pronunciation. It's the Megger-Kalaman test. The Megger-Kalaman test. So, very simple despite its somewhat awkward name. And all we do is we sprint upstairs. What? Sprint upstairs, come on. So it's a simple thing. So you might be thinking, how many stairs? How steep are the stairs, and so on. I also ask those questions too, but this is how we calculate. What we do is let's put this in the brackets, we take the weight of a performer, we multiply that by the stair height, and what we mean by that is, let's say that you go up these stairs here, you go up some bunch of stairs here, well, whatever this distance is between here and here, whatever that distance is in meters, that's going to be the stair height. So we take the stair height, multiply it by your weight, and basically divide it by time. Now, anyone who studied a bit of physics will know that that's effectively work done. It's the same concept. And of course, what we're doing here is we're taking a reading of power. Okay, so because we're dividing that work done by time, it gives you a reading of power. So positives in a slightly different green. This test is very simple. You just need some stairs. But the other thing you need, and this is the negative, is that you do need a run-up. Okay, so we do have a run-up to these stairs. So you might want to think in your life, how many stairs do you have where you can take a run-up from distance and still leg it up those stairs? There's probably a limitation. Now, the only thing I want to add before the end of this video, as I flick back my page, the only thing I wanted to add is that we've got a number of tests from GCSE. I just want to mention, in case anyone hasn't studied that, if you have studied that, you might feel this is not relevant to you, but from GCSE there's some other tests we might want to be aware of. First of all, we have a vertical jump test. That vertical jump test, where we measure the difference between our standing reach height and our jumping reach height, is a good test of power. We want to remember that we have our hand grip dynamometer, that hand grip dynamometer, which is a measure of strength. I want to remind you that we've got our Illinois, crazy spelling for an American state, We've got our Illinois agility test, which is kind of that weaving run where you start face down on the floor. We've got that test. You should have studied at GCSE. If you haven't, just go and have a little Google and research of it. We've got videos on it too. We have 1 minute press up. We have the 1 minute press up or sit up test. And these are to measure muscular endurance, okay? So just remember that from your previous studies. We have a test called the abdominal conditioning test, which is also a bit like the multi-stage fitness test, is by the National Coaching Foundation. Again, it's for muscular endurance. And finally, I want to remind you of the sprint test. And I'm going to make reference to the 30-meter sprint test, even though there's numerous other formats of it, which is where we take a rolling start and then we run as fast as we can for 30 minutes. And of course, that measures speed. Now, if any of these that I've just referred to are not familiar to you, I would recommend you either go and Google them or you use our other video material to look at those in detail. Because how could I forget? We've also got the sit and reach test for flexibility. So that's also inside that box. If you don't know this test, I'd recommend you go and have a look at them because potentially you're going to need a broad knowledge of them going forward. That's all from this recording. Cheers.